Hello, and welcome to this week's episode of I Came for Science, a show about sex and reproduction and inclusion in STEM. I'm your host, Laura Surratt. I'm a professor of biology, and I've been studying animal sex for the past 30 years. Please join me as we normalize talking about sex and what we know about it, as well as the journeys of the scientists who study it. Today's episode follows up on our last episode on reproductive losses. In our last episode, we explored reproductive losses in humans, and in today's episode, we explore reproductive losses in non-human primates. We speak with Dr. Jacinta Beehner, professor of psychology and anthropology from the University of Michigan. She is a co-director of a number of primatology research projects, including the Simeon Mountain Gelada Research Project in Ethiopia and the Capuchins of Toboga Research Project in Costa Rica. Much of her research is focused on female reproductive strategies in non-human primates. Thank you so much for joining us, Jacinta.
Thanks so much, Laura. It's a pleasure to be here.
I'm so happy to have you here. So I wanted to start by asking if you could share with us what your general area of reproductive biology that you study is.
Sure. I've always been kind of fascinated in the arms races that we see in the animal kingdom. And so arms races, they occur when the interests of both parties don't align. So usually we think of predator and prey. Predators want to have dinner, prey don't want to be eaten, or parasites and hosts. And while all of these arms races actually fascinate me across all different theoretical domains, I think the one that I'm always been most interested in, and the one that my research focuses on, is the arms race between males and females. And this is often called the battle of the sexes. And I should clarify here that I'm not actually all that interested in the battles you may be thinking about, the audience anyway, because like the stereotypical gripes between men and women, these are actually less interesting to me because in humans, men and women's interests actually align a lot more than most mammals, simply because most humans are monogamous or mostly monogamous. And, when you hear about the battles that I'm interested in, you'll see what I mean. So I'm really more interested in species where the male-female battle of the sexes, where a new male might come in and kill the offspring of the mothers who are currently there. So these are pretty extreme, divergent reproductive interests between the males and the females. And so then I'm interested in, mostly is the alternative. What do females do when a male does this? So this process is seen across all of the different orders of mammals. It's known as infanticide, where a male comes in and kills the offspring. And most of my research has focused on how do females counter this extreme male reproductive strategy. So clearly it's bad for the females to have their infants killed.
Can you share with us for a second, what different species does this process of infanticide happen in?
I think the one that maybe most people are familiar with are lions. A novel new male will come from outside the group. He enters the group. At that point, there are females with offspring, and the male will not be able to mate with them. They won't be fertile until they wean those offspring. And so rather than wait for the female to wean, he kills the offspring. And remarkably, those females will come back into estrus, become fertile again, and he'll be able to mate with them. So it's a process of speeding up his own reproductive success. But of course, it's at a huge cost to the females. And we see this in a lot of primate groups. Any primate where we have a steep reproductive skew. So in other words, that one male does most of the mating with the females in the group. Whenever you have that system, which is common across primates, this is a really effective strategy for males. So then how do females deal with this?
Right.
That's really been where my research lies.
But what led you to this particular area of being interested in conflict between males and females and how females respond to this conflict?
That's a good question. And when I talk about it with my students, we always cover male strategies first. So I talk about sexual selection as a process by which, it is sort of a different form of natural selection in the sense that males are competing for access. Well, males and females are competing for access to reproductive opportunities. So I introduce that. And at the end, I always say, I find males so boring because there really is almost no theory. It's males fight and the stronger one wins. That's mostly what it is. If there's any theory at all, it comes in sexual signaling, where males pretend to be strong or are strong and signal it. And so how does that communication signal strength or weakness? And so I find that a little bit richer theoretically, but it really is quite dull in when you just have a chapter on male reproductive strategies. And it's not until you get into the female reproductive strategies that things start to take a way more interesting approach, because now you're getting into game theory. You start to look at even social networks. And for my own work, so I'm trained as a behavioral endocrinologist as well as an animal behaviorist. We start to look at physiology. And even though there's many behavioral strategies that people have highlighted over the years about how females might counter infanticide, my research really focuses on the physiological strategies that females employ to counter infanticide.
So I was wondering how this research that you've done, maybe you could just tell us a bit about your findings so far, some of the findings you want to share with us about what are the different types of reproductive decisions that female non-human primates make, what species you've worked with, what are some ways that female non-human primates respond to reproductive losses, how we would define reproductive losses in those species. And then what are the evolutionary hypotheses for the reproductive losses and female responses to them? So I kind of want you to go wherever you want with those questions, but kind of talking about your research in the context of reproductive loss.
I want to just start out answering this question by saying I might be using the word decision. And for your audience, I want you all to picture me putting my fingers up as fake quotes around the word decision, because the decisions, especially with my area of study, which is physiology, it really is a mechanistic process by which females' bodies make these decisions. And I'll get into some of those in a bit. But
and is that true in humans too?
Well, no, I mean, yes, it is true in humans. Sorry.
Yeah.
If you think of women who want to get pregnant, but because of excess stress in their lives, they're unable to get pregnant. Or if you think of miscarriages that happen in humans, in women who are under stressful conditions, these are women who want to get pregnant. These are women who want to keep their pregnancies, and yet their bodies, due to some signal, some kind of the excess stress, they fail to ovulate or they miscarry. The body is making a decision, in quotes, based on the likelihood of success. And so our bodies, through evolutionary time, will kind of make these decisions about prospects for success. And if in fact there is a signal that this is not a good time, this is not a good environment, our bodies will shut down. And so that is a decision. And I usually tell my undergrads to think about the fact that these women would prefer to keep their pregnancy and they miscarry. So the same process is happening in the animals that I'm talking about. Okay. So what happens? Well, there's really two things that I study the most with respect to physiology. One is what I call a mitigative strategy. They're mitigating. They're basically making the best of a bad job. So remember, we're talking about infanticide, and we're talking about species where when a new male arrives, he's going to kill the kids that are there. He's going to, speed up his own ability to mate with.
And how young kids are we talking about? Like if they're 3 years old, would he kill them? Or,
It depends on when females can get pregnant. So for example, usually it's at the time of weaning. With most primates, a female needs to wean her previous offspring before she's able to become fertile again. There are species that can become pregnant while they're lactating. And so in those cases, we tend to see less infanticide because the female can actually turn over her own pregnancy faster. Even though she's lactating, he can mate with her and she can get pregnant. And so there's less of a urgency. There's less selection pressure for infanticide to occur in that species. But in most primate species, like the species I study, white-faced capuchins, and in geladas and in baboons, the females they cannot get fertile if they are still lactating. So males will kill the offspring and then bring the female. This brings the female back into a fertile state. He can mate with her far sooner than he would if he hadn't killed the offspring.
Right. And just for our audience, these are not the males that are the father of these offspring they're killing. It's new males who have come into the group, right?
Exactly.
Yeah. Okay.
They're not his kids. And they, and again, the male also is not aware of what's going on in any kind of calculated, I need to increase my reproductive success way, the male just comes into the group and is frustrated because a female is not mating with him.
Mhm.
And of course, his anger and frustration ends up killing these kids. So, there actually is very little research on how the males
Right.
then decide which infants they should kill and which ones they shouldn't kill.
Mhm.
So the strategy, so a male comes into a group, he's most likely going to kill any offspring that are not his. A female who's pregnant is able to we've found that in our geladas, and this actually occurs across many rodent species as well, and possibly horses and dogs. So those are the species where we've seen it. Pregnant females will abort. What we've seen in the geladas is that because we are able to see when they're pregnant using fecal hormones, we don't capture our animals and draw blood. And the only way to really get hormone levels is to get at some form of biodetritus, is what we call it. So someone might get saliva or hair or urine. We do fecal samples. They're non-invasive. They're always there. Animals
Mhm.
poop all day long. So we can
Mhm.
easily track their hormones as they move through their day.
Wow. So you can look at the hormones in the poop, basically. That's
Exactly. It's
amazing. Is there a distinction between abort and miscarry in non-human animals?
a good question. I do think of maybe abort as a strategy, like a little bit more of a physiological adaptive strategy that a body does.
Mhm.
Whereas there are cases where pathology leads to miscarriage. So
Mhm.
a genetic mutation or
Mhm.
a chromosomal mutation, something that
Right.
is
Yeah,
actually
the embryo is not developing
exactly,
correctly.
or
Yeah.
it didn't implant correctly.
Right.
Those types of things will also miscarry. They're less selected for. They're not
Yeah, I guess maybe the distinction is like one is a response to the environment in non-human animals, like a stressful environment maybe would lead to the spontaneous abortion in non-human animals, whereas something developmental that's happening with the fetus or embryo could be considered miscarriage. I don't know. I'm just throwing this
no,
out, but yeah,
and actually the word
yeah,
spontaneous abortion is a good one because that's sort of
yeah,
a compromise between the two.
right.
Abort is a verb and it does sound
Yeah.
very active. Spontaneous abortion does capture it a bit better because it makes it less conscious. I mean, it is
Mhm.
less, it's not
Right.
conscious at all, but
Yeah.
the word spontaneous does kind of imply a little bit more of that.
Yeah.
So these females will spontaneously abort in
Mhm.
response to basically the body receiving a reliable cue that their offspring are doomed. And I use that word doomed. Some females escape, in other words, they give birth to their infant anyway, and their infants do survive, but it's rare. And
Mhm.
in fact, across like almost 15 years of data, we keep looking back to see, and we only have a handful of females who, when they keep their baby, are escape infanticide. And so mostly females, there's been selection for their systems to abort.
Mhm.
And it's up to 90% or something. So
Wow.
it's really incredible how strategic this approach is. Like we almost always see when a male comes into the group, the females abort, all of them.
Mhm.
So if there's a
Mhm.
bunch who are pregnant, they all show signs of
Wow.
abortion. And so the idea is, of course, that they're making the best of a bad job. Of
Mhm.
course, it's not great to lose your offspring, but better to lose your pregnancy earlier than later. So the
Mhm.
more, in evolutionary terminology, energy and time is the currency that we're dealing with. So females, they only have their lifetime to produce their offspring. And so they really do benefit when, if something bad's going to happen, let's get it over with. And let's
Mhm.
align with this new male and we'll just, have him, we'll sire offspring with this male.
Mhm. That's one kind of strategy we could say that females of how females respond to kind of the conflict between males and females over infant survival. Are there other ones like do females ever not allow males to come into groups to begin with?
That's a great question. And so the strategy I just told you about is like kind of making the best of a bad job. But we do
Hmm.
see a whole bunch of other strategies that
Okay.
fall under a category that I would call preventative strategies.
Ah,
So
gotcha.
rather than making the best of a bad
Mhm. Yeah,
job,
you call them mitigative, is that right? Yeah.
I don't even,
Yeah.
it's,
I like that.
it's a form of mitigate. And I
Yes, yes.
struggle to say that.
So
These are
preventative.
now
Yeah.
preventative strategies.
Hmm.
So And these can fall under two categories. One is behavioral, and most of the research in the area of counter strategies to infanticide prior to some of my own work really focused on this, the behavioral strategies. So, in other words, you might solicit the father of the offspring to help protect your offspring, to protect your vulnerable offspring. So we call those, at least in primates, we call those friendships,
Uh-huh.
but really it's a protector role.
Hmm.
Females might gang up together to mob a male.
Hmm.
You had said maybe they keep the male out of the group. In
Yeah, like if
primates,
a new male is trying to come in. Yeah.
that's not so common, at least
Okay.
on the part of the females. Of course, the
Gotcha.
male is trying to keep the male out, uh,
Right.
who is probably the father of the offspring. Oh, and confusing paternity. So
Ooh,
females,
what's
while
that?
they're fertile, will often mate with as many males as they can
Hmm.
in an effort to confuse paternity, and
Mm.
has two outcomes. One is that if those males, the males that she mated with, if one of them were to become the next alpha, of
Hmm.
course, it's likely to kill your offspring.
Ah.
But second is that, and probably more likely, since most of the males will come from outside the group, so there's no possibility that in many cases, there's not a possibility that you would have mated with
Hmm.
a new male. But if you've mated with a bunch of the group males, you have now many protectors for
Hmm.
offspring. Um,
Right. Because do males not have a way of knowing whether it's their own offspring?
No, well, again, I study
Oh, we
primates.
do.
In
Yeah.
primates, there can be associative mechanisms, but they don't have any, we have no evidence that a male primate is able to detect his own offspring using something like MHC or scent or
Right.
some other mechanism.
So, just for our listeners, MHC is the major histocompatibility complex, and those genes are involved in immune response, and they're hypervariable. So, there's some evidence from both humans and non-humans that individuals can recognize other individuals that have different or similar MHC alleles to them. So, yeah, but there's no evidence that males are doing that with their own offspring.
So far, there have been some studies that try to identify paternal kin recognition, where fathers recognize their offspring in
Mm-hmm.
primate, and most of them turn up very weak results. And the ones that turn up results where it does appear that fathers recognize their offspring, it's usually based in association. So
Mm-hmm.
fathers have associated with the mother, they become more familiar with the offspring, give preference to offspring due to this overlap rather than
Right.
any physiological recognition.
I have a funny question for you. So in humans, what would we do? We would look for physical characteristics like, oh my God, he looks just like the mailman or whatever. Um, so can you recognize in primates similarity from between like parents and offspring physically?
You can. I mean,
Oh,
it's really striking in
yeah,
some of the species I've studied. You know that that's that family. Oh, and they
right.
have this trait that's clearly that family.
Interesting.
So I think humans, for sure, we see the recognition across
Hmm.
families of certain traits. Whether the primates themselves recognize it, we don't have evidence that they do, but
Right. You could
it
totally
seems
test that though. Yeah, that's
exactly.
interesting.
The
Yeah,
the information is out there. We
right.
just don't know that animals are taking that in.
Hmm.
So we have these behavioral strategies
Right.
to prevent infanticide, but I'm more interested, of course, in the physiological ones. And there's one specific physiological preventative strategy that I study, and it's just completely captured my fascination. And it's something that we call deceptive fertility. So this is the process by which a mother, so she's currently a mother, she's lactating, she
Uh-huh.
has a dependent offspring. She revs up, again, this is a decision, but her body does it outside of any awareness. Her body revs up her ovarian hormones when a new male arrives in the group in such a way that she is able to produce false cycles. And in the case of baboons
Really?
and geladas, they actually have external signs of fertility, which are called sexual swellings.
Mhm.
Some of your audience may have seen the swellings in the bottoms of these baboons. Geladas actually have swellings on their chest, but it's a very
Mm.
visible sign of fertility. It's a female who has offspring dependent on her, and if you're just watching her, she looks like she's returning to fertility, and she
Mhm.
behaves in such a way that she's returning to fertility. She's attracted to the male. She walks up to him, she presents to him, and he mates with her.
Uh-huh.
Whole time she has this very vulnerable infant, riding on her back or carrying or walking along the side of her. And so she's overcoming this fear of a new male in order to approach him and mate with him. What
Okay.
we've shown is that these cycles are not fertile. We don't really,
Really? Wow.
well, we don't know
That's
why
huge. Yeah.
we don't know why they're not fertile. So we don't have,
Mm,
with fecal hormones, it's hard to pinpoint exactly what's happening, but
mhm,
it could be that they are not ovulatory. It could be that they are not conceptive. It even could be that they're just not, they don't produce a pregnancy down the road, or
mhm.
pregnancy doesn't last.
So
We
the
don't know
outcome you see is that they don't end up pregnant from these.
exactly.
Okay, gotcha.
Yeah. We make the presumption that these are I think we call them non-conceptive cycles, but we don't
Okay.
actually know whether they're non-ovulatory, non-conceptive,
Right. Which
or
step?
but the point is that it is more than an accident, and it is these females are continuing to lactate based on our
Wow.
observations, and they raise these offspring successfully. And so that suggests that they are faking it. They have this fake cycle that confuses the male. And because he's able to mate with her, we assume that's the reason he doesn't exhibit aggression towards her and her offspring. And so the infants live.
Were you the first person who realized this?
So the work in Hamadryas baboons was actually some of the first work to show this. It was done by Dietmar Zinner and Tobias Deschner. And they have a publication in 2000 that really highlights this idea of deceptive fertility in Hamadryas baboons.
That's still relatively recently. Like those baboons have been studied for a long time. So it took a
Yeah.
while to realize that. Okay.
But that was a really influential publication for
Yeah.
I was fascinated. That was one of my favorites all along.
Huh.
One of the things that they were unable to do, just because it was a wild population, was to establish systematically that this was something that went on. It was
Mhm.
a little more anecdotal in the way it presented the data, but it also was unable to look at the success of the strategy.
Mm.
So I believe that our work, and it's actually in review right now.
Oh, congratulations. That's
Oh,
great.
thank you. It's been a long time coming. Our work is, I believe, the first to systematically show that this appears to be a strategy on the part of
Uh-huh.
these females, and also that it works. So if a female shows a sexual swelling and continues to lactate versus a female who doesn't exhibit a sexual swelling and continues to lactate,
Mhm.
it's the ones that do exhibit this fake sexual swelling whose infants live, and the other ones have their infants killed by infanticide. So we were able to show that it's the female is far more successful at raising her offspring and preventing infanticide if she exhibits a sexual swelling, which
Mhm.
and we do observe that these are associated with then mating with the male. It's just
Right.
that data on mating is less systematic. Like we're
Mhm.
better able to show the sexual swellings than to show the
Right.
mating.
Is that because you might miss the matings because they happen quickly? Or, yeah.
Exactly. Whereas the
Okay.
sexual swellings, they keep for days on end.
Right. Wow. That's huge. Very interesting. I know my listeners are going to want to know how this all applies to humans. And so before we talk about that, I just wanted to put in a little reminder of something that we learned last season, which is about the naturalistic fallacy, where when we apply things that come from evolutionary biology or comparing to other species, it doesn't tell us anything about the morality of the behaviors in humans or the inclinations towards behavior. So, just a little warning before we go into applying some of this to humans. So, that said, how do some of these concepts that you've been discussing and that you research play out in humans or apply to understanding human behavior or human psychology?
Yeah, I do get that question a lot. I tend to punt when I get it. I'm an animal behaviorist and I don't get into humans as much, mostly because there are so many controversies involved. And the strategies I study are strictly in response to male infanticide. So male infanticide has to be a huge selective force in the evolutionary history of a species for these particular strategies to evolve. I'm not saying that infanticide doesn't occur in humans. There is evidence, obviously. Now we could debate about whether it has been or is a selective force in humans, but I'm gonna, for the purpose of this podcast, say I don't think so. We don't see evidence for these particular strategies in humans as possibly as a result of infanticide.
Mhm.
However, I do think that the human body is able to perceive cues in the environment that indicate whether it's a safe or not safe environment to reproduce within. And we know this really is that stress affects fertility in all its forms. And so the ability of the physiological system to make decisions to shut down or to perform do take in information from the amygdala, which picks up on fear. and danger. They do take in information from our metabolic system. Do we have enough calories? Do we have enough fat? Can we reproduce? And so there are these kinds of physiological shutdowns and ramp ups that correlate with the environment around us. So I guess that would be where I would feel safe saying that my results apply to humans. But as far as the specifics of the countering infanticide and,
Right.
like if a woman who's pregnant gets a new boyfriend, is she going to abort? I don't think
Right.
so.
No. Yeah. But that our bodies have been selected over many thousands of years to respond to stressful cues in the environment in a number of different ways, including those that affect our reproductive outcomes. Yeah.
Exactly. So
Yeah.
if she enters a relationship that's abusive, maybe she would abort, but it's due
Mhm.
to the stress and the abuse and not the arrival of a new male. Oh,
Right.
and I
Yeah.
just to clarify, in the geladas where they do have this spontaneous abortion, the females, the males are nice to them. The males are not chasing
Oh,
them and abusing them. The males are
right.
running up to them, greeting them,
Mhm.
nervous, grooming them. So when they abort, it has nothing to do with any kind of what would be stress.
So you only see kind of the violence when males are killing the infant themselves.
There is some evidence from yellow baboons where every once in a while a really aggressive male will enter the group. And these aggressive males, it's rare. Mostly the males enter the group and slowly climb the ranks and it's all peaceful. But they have a few of these aggressive males that will come into the group. They will kill offspring, but it's again, like I said, it's rare. And they also throw females around. And often if a female is pregnant, she will abort. But we don't call this the Bruce effect. The Bruce effect really is a decision. It's a selected for evolutionary strategy on the part of the female to mitigate her loss. We call this, what's happening in these other baboons, feticide.
Mm.
So even though it appears to be the same, feticide, spontaneous abortion, the actual cause of the death of this fetus is different. Bruce effect side, it's adaptive, it's a female aborting, it's her body sort of shutting down. Whereas on the feticide side, it's basically infanticide, but at an earlier stage of reproduction. And
Physical
so
abuse. Yeah.
that's kind of one of those cases where you kind of really do need to have detailed behavioral as well as physiological data to
Right.
understand that difference. I think of it as who's winning? Who's
Mm.
winning the battle of the sexes?
Mm-hmm.
And in the case of Bruce effect, it's the females winning,
Mm.
at least not losing.
Mm-hmm.
In the case of feticide, it's the males winning.
This all reminds me of my very first primatology gig where I was following around rhesus monkeys at Cayo Santiago, and I'd follow around estrus females. I was working with John Berard and write down everything they did. And what stuck with me most, so many interesting things stuck with me, but sometimes females would go in a place where they were pretty hidden from the rest of the group and mate with a male who was not a dominant male. And if a more dominant male than the one mating came along, he would interrupt it and attack the female. And I always remember that. I was like, well, why didn't he attack the male? And I made up hypotheses in my mind of why he might have attacked the female, but it never occurred to me that it occurred to me as a behavioral deterrence so that maybe the female wouldn't mate with other males, but I never thought about maybe it's a physiological deterrent as well, like maybe making changes in her reproductive tract or making her eject the sperm or anything like that. Do you know anything about that?
That's a really interesting question. I've never thought about that particular scenario. And of course, that scenario does play out across many primates where the dominant male will attack a female who is mating with another male. And if he attacks the female over the male, it's because she's less likely to cause damage to him.
Oh, right. There's that.
Males
Yeah.
are usually twice the size of
Yeah.
females. Not
Yeah.
usually, but they can be up to twice the size.
Mm-hmm.
But whether or not his causing her a little bit of stress can interrupt the actual process, I'd have to look at the short-term data from maybe rodents or something.
Well, this has just been a fascinating, really informative conversation. And I appreciate thinking about other species in the context of the reproductive losses that I talked to my colleague, Dr. Krista Craven, about. Yeah, I just want to thank you so much for joining us on I Came for Science. And I look forward to seeing your research as it comes out.
Thank you so much, Laura. It was a pleasure to be here.
And thank you all for listening. Thanks also to our production team, Isabel Espinoza, Lane Patton, and Daphne Trilliana. The music used in this episode is from I Don't Smoke by the Mythical Score Society.